Okay, well, I picked up these two monitors from the office. I offered to take a look at them, see if I could fix them. They are Samsung Syncmaster 2443, so 24-inch LCD monitor. And being Samsung, I kind of thought it would be the usual bad caps in the power supply, because the actual symptom was the monitor is totally dead. I mean, this is plugged in, but it actually would do literally nothing. No lights on the front, no sign of any life at all. So this is how you fix them, because these two monitors both have exactly the same fault, and it has nothing to do with the power supply. I proved that because we've probably got about 50 of these at work, so I pinched a working one, swapped the good power supply in, and it still didn't fire up. Now, the power supply in both these monitors look absolutely perfect. There's no sign of any bulging or leaking caps. Not that you can always tell visually if the cap is bad. I have seen caps in some amplifiers I've worked on that look absolutely pristine but are completely dead. No signs of leaking top or bottom, no bulging vents, just dead. So, I'm trying to get this in shot. There's the second one down here, which is ready to be dismantled. Getting the two sides apart is probably the hardest part about getting it apart. There's no screws, it's all just plastic clips together. You can do it by hand. It's in the middle, you can get a bit of flex on the plastic, and you can pop the two sides apart. In the corners, you can open it to the extent where you can see where the clip is, and just a very fine screwdriver or the tip of a knife, actually, butter knife, will pop those open quite well. So it lifts off. Inside, we have this. Again, with these monitors, like most LCD monitors, the actual case and the back provides all the support. So once the back is off, all of this is just loose and kind of nasty. This shielding pops off quite easily. There's clips at the top and clips there. You just need to push on the corner there and on the corner there, and it pops up and unhooks. You just pull out I suppose this is the cold cathode light feed for the high voltage cables. Pull those off. This is the button or the control feed. There's the ribbon cable for the data to the screen, which you can just peel that tape off, pop that out, and then the whole internal unit just lifts off. So, usual two-board setup, power supply on the left, the brains of the unit is on the right. Now, the fault on both of these monitors is actually on this smaller board. The power supply, I did go over it with the ESR meter. All the caps on there are fine. They don't have the usual crappy caps on brand 10-volt caps that have sent many Samsung monitors to an early grave. So what we need to do is take this board out. I've already had this apart, so the hex screws on here I've already taken off. Need to get rid of those. Single screw. Keep this in shot. Single screw. That pops out. And the board just lifts out. So, undo the ribbon, under the power cable. There it is, the faulty board. Now these are available online, but the guy who's selling them wants about 50 quid for each, or sorry, 50 bucks for each board, and about $50 shipping as well. So you're looking at $100 to repair a monitor that's probably worth about 80. So I don't know how well he's going selling those, at least internationally. Now the fault on these boards, it's been exactly the same fault on both of these monitors. The one behind me that's actually been rebuilt is working perfectly now. And the fault is these two capacitors. There's 4 caps on the board. They're all 100 microfarad, 16 volts. Now the ESR, the equivalent series resistance of a capacitor of that rating, according to my ESR meter, should be 100 microfarad, 10 volt should be 100 microfarad, 16 volt should be 0.6 to 0.9. These tend to be quite high on this chart I found, so I'll be looking at something more around 0.6 as a happy reading for these. 0.9 maybe. If you can actually see if you can work out what the manufacturer's mark on these are, you can actually look up the data sheets and find out what they really should be, rather than relying on a generic chart, because not all caps are the same. But I don't recognise the symbol on here, and I've got nowhere to tell Google what that symbol is. So in general, if you've got a board with multiple caps of the same make, same value, they should all have the same ESR. So if you go around and find ones which are wildly different, like factors of double, triple, quadruple, you know that something's wrong with the high ones. Now, the ones on the edge here on the other monitor are totally fine, so I've just zeroed out that. Now this is going to work on this phone. So 0.57 for that one. So again, closer to the 0.6 I was looking for. Short focal range on this camera. And this one here is one of the ones that was bad on the other one. 1.1, so we're looking at almost double that. This is the other one which was bad on the other one, the other monitor. 0.9, again quite high. And this one was one that was good. 0.17. So that's quite low, but I'm not too worried about low. It's quite hard to get a good connection or a stable connection. 0.91 ohm roughly. So that's low, these two are high. Now these are the ones I took off the other board. They're just little surface mount, wet electrolytics. And a bit of a pain to desolder, but you can replace them with normal capacitors. I mean, there's about 2 or 3 centimeters clearance where this board is in the case, so size isn't really, height of the component isn't really a big issue. So what I'll do, I'll take those off the board, replace them with normal capacitors that I just solder onto the pads, and we'll fire this thing up and see if she lives. Right, we're in the workroom. I found a couple of caps I can transplant on. They're just the bog standard 3-hole caps that are fine. These are just used because everything's made surface mount these days. These are virtually the same component, just in a different form factor. I actually recover these from smashed up TVs I sometimes find beside the road when someone's had the coil off the tube and the board's lying there. Just because the capacitor is old doesn't mean it's a bad cap. They either leak or they don't, or they're either in an environment which basically knackers them, i.e. somewhere where they get hot, or they're not. So just because they're second-hand doesn't mean they're bad. And I've checked the ESR on these, and they're about 0.5, which is what I would expect. It's also worth noting that with bad capacitors, it's not the capacitance that changes. Often that is roughly within spec. It's the ESR that changes, the equivalent series resistance. So it should have a very low resistance. As they age and dry out, the resistance goes up and up and up, and you find that it's effectively like dropping in extra components into the circuit. So if something's very finely, or something's very critical, you may find it takes it outside the critical range and it won't work, which is often why bad caps in power supplies go bad, because they're fairly critical. They've got to be low ESR, and tend to get driven quite hard in modern switch mode power supplies and run quite warm, which is never a good place for an electrolytic to live. In terms of getting these off, you can do it with with a normal iron. What you really should do is add some solder to the joints, just to wet them, get some flux in there. The problem is these are actually stuck on quite long pads, and the contacts go a long way in. So what I'm going to try, and I've never tried this before on these anyway, is a stuff called quick chip. It's very low melting point solder, so it forms an alloy with the existing solder, and it's such a low melting point that it actually remains wet for maybe 10-15 seconds after you take your iron off. So you can actually get both sides wet at the same time. and in theory lift the bad cap off. But like I say, I've never tried that before, so here we go. On the other one, I just melted each side, added some more solder, and wiggled them loose, which was somewhat successful without causing much damage to the track pads underneath, but they are quite big pads, so it doesn't seem to cause it too much harm. May not work because it doesn't seem to be wetting very well. What I'll do, I'll add some new solder, and that took it straight under. This can be quite fiddly. I mean, you could just rip it off, but you're going to lift tracks and cause damage, so just bear with me on this. This quick chip method doesn't seem to be working. It's very good for removing multi-leg. There we go. It is actually working. Staying wet on both sides. Bingo. Okay. It has caused a little bit of lift of the plate, but that's not a problem. There's enough metal there to solder to. So what I'll go for now, if I can find it, is my solder whip to try that out. Well, I have actually got a desoldering iron, but that, of course, at the moment is blocked. Okay, I hope that was all in view. So this stuff just absorbs solder, mops it up. It does look like a bit of a mess. In fact, it does spread out a bit, but it's not a problem. Add fresh solder and it all beads back to where it should be. It's probably not the prettiest joint in the world, but it'll do. I won't show you fitting the second one because that'll be a very long, tedious video. Come on, solder wick. Get up. This doesn't actually make much difference. It's all going over the original solder mask, so it's not actually making contact with anything. It just comes straight off anyway. It's a bit alarming, I guess. Right. So now, of course, I wasn't paying attention, so I don't know which polarity that capacitor was. Should have made note of that. Pretty sure. I'll take a guess. I'll check on the video anyway before I power this up, but I'm pretty sure it was going to be that way round. So I just bend these legs to make a little foot. Like that. Place it onto the, just turn the joints a bit more, give it something to go into. And place the, so you can't see through my hand, but you can spread the legs a bit on this. It's too close to the joint for my liking. Close to the break in the solder, so I don't want to bridge anything. most that was out of shot. But there you go. There's one of those fitted. So all I'll do is I'll go back and check I had that the right way around. I'll replace this one, and in the second video we'll put it all together and give it some... Well, as expected, I had the, the last cap round the wrong way. So I'll fix that. I've also taken the second cap off. It's a lot easier to do that without the camera in the way, and also works a lot better if you add normal solder first, then the chip quick, and also use the vacuum desolder tool, which I've just cleaned out, rather than using the solder wick, which is horrible stuff. So tin these. Also makes soldering to it easier because it means all the chip quick is gone, so you actually get a solder joint that actually grips quite quickly rather than sits there for ages while it cools down below its very low melting point. And there are demos of people with molten chip quick in their hands, but it's still going to be a bit painful. So again, I'm going to have to check whether this cap is the right way around, but I'm pretty sure that the negative lead faces north on the board. So I'll just sort the legs out on this new capacitor, the donor cap. So the camera's sitting on the edge, on the side like this, but it's the only way I can do this with the very short focal length of the iPhone. I've also given the board a quick tidy up, quick clean with what is it? Isopropyl alcohol, which gets rid of all the burnt flux and actually makes it look much neater, much less bodgy. Yeah, there's still chip quick in these joints. It doesn't matter, but it makes them look rather dull. Again, it's on top of the mask, so it doesn't actually matter. Right, and there we have the two new caps fitted. It looks a bit odd, but it's electrically just the same as it was before. So what I'll do is go and plug this back into the TV, assemble it enough to give it a test, and we'll see where we're at. Alright, I've checked the polarity of the caps. They are correct. Always worth checking because they tend to go pop if they're put in the wrong way around. So I'm going to just reassemble this board. Plug in the ribbon cable first to help. So it slots in, clamp shut. Plug in the power lead. It lines up in the mounting groove inside there. Simple screw to fix it. Not sure why this wire clamp is even there, but there originally. So this bracket here aligns between two of the plastic clips at the top. The ribbon in, a bit fiddly. It's lying flat with the cushioning underneath the metal so it doesn't rub through in time. Plug these babies in. Now what I'm hoping for when I power this up is the usual little box that drifts around the screen saying it's got no signal. It's a lot more than it did before, so like I say, it was totally dead before, had no signs of life. So in cases like that, it is reasonable to expect the power supply, but in this case it seems to be the video logic board was dead. So because the case is structural, I'm going to have to turn this over, just prop it up like that, so we can get a demo of it working or not working. The moment of truth. The blue light didn't even come on before, so in theory, any sign of life is going to be improved. The mains on the wall. green light, and a little thing saying, give me a signal. So I guess we'll put the back on this and put it back on its stand and connect it up to a laptop and just check that everything is happy. There we go, check signal cable. The previous owner of this likes jabbing at his screen with his fingers. Well, I've learned before that you should never really put things fully back together before you give it a proper test, so this is a proper test before I put the back on, and everything is looking very nice. So I will call this a job done, put the back on, fit the stand, and, these can be considered fixed and released back into the wild. Now I've actually got a very nice monitor at home, so I'll take these back to the office. And I actually don't have a monitor at the office for some reason, so I'll pinch the nicest one of these and call that my own at work. So, like I say, the back of the screen is structural. It holds everything in place, so everything's lined up. And then we just drop the back on. Close up the case. Everything is now nicely aligned. Drop the stand back in. And give it one final test. Now there are 4 capacitors on the board. You could, in theory, replace all 4 of them. 2 were good, 2 were bad. So I suppose if you're going to sell one of these, you probably would replace the 4, so you don't get any comeback. But as soon as if these go wrong again, they're going to end up on my desk. I'll probably risk it, fix it if it needs to be fixed. Otherwise, probably okay. Get the power on again. Job done. Screen doesn't get empty pretty much. So, 2 potentially landfill monitors fixed for, I don't know, 20 minutes work and 3 parts really.